is better. Okay, so condensing. I'm using the properties. Two logs separated by subtraction can be combined using division. So we've got 2x plus 5 divided by x. And that's all you got to do. On this one, anything that's in the front, you got to move to the back as a power. So this is actually natural log of x to the 1/2 plus natural log of y. So two things separated by addition can be combined in a logarithm using multiplication. So x to the 1/2 times y. But I don't know, they might have the square root of xy. So either way. And then this one. So each of these needs to be moved back as a power. So that's x cubed, that's y to the 5th, and that's z to the 6th. Addition means multiplication, a single logarithm, so x to the 3rd times y to the 5th, all divided by z to the 6th. And there we go. Solve each exponential equation by expressing each side as a power of the same base and then evaluating the exponents. So what we know is that 64 is 2 to the 6th power, and the only way 2 to the x equals 2 to the 6 is if x equals 6. And so there's the answer. For this one, 64 is 4 cubed, so I can just set 2x minus 1 equal to 3 and solve. So I'm going to add the 1 and then divide by 2, so x equals 2. For the next one, well, 27 is not a power of 9, so I've actually got to rewrite both of them. 9 is 3 squared, and 27 is 3 cubed. So this is the same thing as just saying if 3 to the 2x equals 3 to the 3rd, then 2x has to equal 3. Those are multiplied. And so then x equals 2/3. And then on this one, we've got 3 to the 1 minus x equals. Now this right here is 3 cubed, but it's in the denominator. So if I want to bring it up, then I got to change the sign of the power. So this right here is 3 cubed. So this is 3 to the negative 3 when you bring it up. So 1 minus x equals negative 3. Negative x equals negative 4. X equals 4. Let me make sure on that so I'm not telling you something wrong. Okay, good. Solve, use a calculator to attain decimal approximation. It says to 2 decimal places. Okay. The inverse of an exponential base 10 is a log base 10. So we're going to take log base 10 at both sides, which is just log. And so x equals log of 3.91. So just go to home screen and type that in. Log of 3.91. And you get, so 2 decimal places, so 0.59. So 0.59. Okay. On this one, we're going to first, in order to get the exponential one, we're going to divide by 3. So change colors. Okay, so e to the 5x equals, is that going to that? 19, 77, 3, 6, 18, 17, 5, 15, 27, 9. 659? Cool. Okay, so 659. And then the inverse of an exponential base e is a natural log. So we're going to take the natural log of both sides. And those two simplify each other out. So I'm left with 5x equals the natural log of 659. And then we're going to divide by 5. X equals the natural log of 659 divided by 5. Now, the 5 is not inside the logarithm, so be careful about that, especially when you type it in. So, natural log of 659, close the parentheses, divided by 5. And that is 1.298 or 1.30. Okay. On the next one, we need to get the exponential alone, so the first thing we're going to do is we're going to add the 2 over. So e to the 5x minus 3 equals 10,478. The inverse of an exponential base e is a natural log, so we're going to take the natural log of both sides. So we're left with 5x minus 3 equals the natural log of 10,478. Then we're going to add the 3 over. We cannot add it inside, so we just put plus 3 at the end, and then we divide by 5. So x equals the natural log of 10,478 plus 3, all divided by 5. And we're going to type that in. Natural log of 10,478 plus 3, enter, and then divided by 5. Or you could have done parentheses around all of it, and then divided by 5. Either way, we get 2.45. So approximately 2.45. Okay, so for this one, we got 7 to the x plus 2 equals 410. 410 is not a power of 7. So the only thing we can do is apply the exponent, or the log base 7. So these two simplify each other out, and we're left with x plus 2 equals log base 7 of 410. Last step, we're going to subtract the 2. Log base 7 of 410 minus 2. So, alpha window, log base 7 of 410 minus 2. And we get 1.09, approximately. Alright, number 18. Solve each logarithmic equation. Reject any value of x that is not in the domain of the original. So the only thing you really need to worry about here is when you're dealing with a log equation, you cannot take log of 0 and you cannot take log of a negative number. So log of 0 and log of negative numbers do not exist. Okay? So if you get an answer and you plug it in and you get either one of those situations, then it's out. It's an extraneous solution. Okay, so the inverse of log base 2, the inverse of the operation would be the exponential base 2. So x plus 25 equals 2 to the 4th power, which is 16. X equals 16 minus 25. And 16 minus 25 is negative 9. And so the answer is negative 9. Unless I plug it in, I get log of negative. Negative 9 plus 25 is a positive number, so we're good. All right. For this one, we need to solve for x. It's inside a logarithm being multiplied by 5. So we could move the 5 to the back, but it's easy just to divide. And so natural log of 2x equals 4. You cannot divide the 2 out right now. I have a lot of people that kind of did something like that on the test. You got to undo the operation around it first, which is the exponential. So the inverse of log base e, which is natural log, is the exponential base e. So we do that, and we get 2x equals e to the 4th. Final answer, we divide by 2. E to the 4th divided by 2. Oh yeah, I'm supposed to be telling decimal. So, e to the 4th divided by 2. And that is approximately 27.30. Sorry. Okay. So, for this last one, we've got, oh, no, just kidding, we got another. For this right here, we got to solve for x, so we need to subtract the 6 over. So 2 natural log of x equals, subtract 6, negative 1. Divide by the 2, so that is a negative 1/2. The inverse of the natural log is the exponential base e. So apply e, and then x equals e to the negative 1/2. Now, that is e to the 1/2 power in the denominator, so you can think of it as 1 over the square root of e. But as long as you can type it in, then you're good. So e to the negative 0.5, and that is 0.61 approximately. And for this one, I've got 2 logs separated by addition, which means I'm going to combine them using multiplication. So log base 5 of x times 4x minus 1 equals 1. The inverse of an exponent, or a log base 5, is exponential base 5, so we're going to raise both sides to the power of 5. So I'm left with, I'm going to distribute that, 4x squared minus x, distribute the x, and then equals 5 to the first power, which is 5. You got a quadratic, a linear, and a constant term. Get them all on the same side. Set it equals 0, factor and solve. So we're looking for the, or you could do the quadratic formula. It's just whatever you like to do. The factors of negative 20 that add up to negative 1 are 4 and negative 5. So this would be x plus 4 and x minus 5, but we got to divide by the 4. So x plus 1 and x minus 5 fourths, or 4x minus 5. Either way, if I'm trying to solve for when it equals 0, I get x equals negative 1 and 5 fourths. When I plug in negative 1 into here, I get log of a negative number. So that one's out. When I plug in 5 fourths, they get 5, that's a positive number. And then 5 fourths times 4 is 5, and 5 minus 1 is positive. So the answer is just 5 fourths. Okay. I didn't check these, but 0.61 is positive, so the only x I have is just plugging it in. And e to the fourth divided by 2 is positive, so times 2 is positive. We're good. Okay, last one on this one. Two logs separated by subtraction can be combined using division. So log base 2 of x plus 2 divided by x minus 5 equals 3. We're going to apply the exponential base 2 to undo the logarithm. So we're left with x plus 2 over x minus 5 equals 2 cubed, which is 8. We're going to multiply both sides by x minus 5 so that we no longer have division. And so we end up with x plus 2 equals 8x minus 40. So I'm going to move this x over here, subtract it, and I'm going to add the 40 over there. And then I'm going to divide x equals 6. If I plug in a 6, 6 plus 2 is positive, 6 minus 5 is positive. So that is an answer, or the answer. All right, last problem. It says the formula A equals 23.1 e to the 0.0153 t models the population of a certain U.S. state A in millions t years after 2000. Okay, what was the population in 2000? So 2000 is t, we're talking about t years after 2000. So 2000 is when time equals 0. Time equals 0, anything times 0 is 0, e to the 0 power is 1. You should just recognize that 2000 is the initial, so that is the initial population. That is just 23.1. And that is a million. Now, the other option is you literally plug it in. E to the 0.0153 times 0, and you get 23.1. According to this model, when will the population reach 28.3 million? So the population, 23.1 e to the 0.0153 t will equal 28.3. Now, you could solve this in your calculator by graphing y1, y2, find the intersection. But we're pretty good at this, and it would actually be faster for us just to solve it instead of typing it in and doing all that. So I'm going to divide by 23.1. So e to the 0.0153 t equals whatever that is. And then I'm going to do the natural log to simplify out the e. 0.0153 t equals the natural log of all that. And then I'm going to divide by 0.0153. 0.0153. And that will solve for time. So, natural log of 28.3 divided by 23.1 divided by 0.0153. And that is 13.2698. So 13 points. I mean, they didn't say a decimal. So I guess we'll go with, oh, they're asking for a time. So it's 13.2698. So that's 13 point something years after 2000. So that's going to be in 2013, I guess. Yeah. Okay. And then, I guess you can make the case for it. Doubling time. So last problem, doubling time. The doubling time is how long it takes to double the population. Well, the population at the beginning of 2000 is 23.1. So 23.1 times 2 is 46.2. So the question is, how long does it take for 23.1 e to 0.0153t to grow to 46.2? So we're going to divide by 23.1. And it really doesn't matter what the initial population is because we doubled it. So it's going to be e to the 0.0153t equals 2. We take the natural log. Those simplify each other out. 0.0153t equals the natural log of 2. We divide. And t equals the natural log of 2 divided by 0.0153. And that would be natural log of 2 divided by 0.0153, which is approximately 45.304 years after 2000. So they're saying, well, yeah, how many years? Okay, so approximately 45 years. And that's the review.